Welcome to 6.1 and 6.2 of the mole. Pause and do these warm-up questions and then press play. Looking at problem 1, a particular small laboratory cork weighs 1.63 grams. So we can write that as 1 cork equals 1.63 grams. How many corks would there be in 500 grams of such corks? We're going to start with 500 grams. Draw our line for converting. Whatever unit you start with needs to be at the bottom, and that's grams. And we are going into corks. So 1.63 will be at the bottom and 1 cork will be at the top. If you put this into the calculator, you can put that as 500 parentheses 1 divided by 1.63 end parentheses. Our units will cancel, leaving us with corks, and our answer would be 306.748 blah 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 corks. It's asking how many corks would there be in 500 grams. If we rounded up, we would be over 500 grams. So I actually want to round down, thinking about a business perspective. So there would be 306 corks in 500 grams. Second problem, the weight of an empty box is 213 grams, and the weight of a box plus a bunch of big nails is 1,340 grams. The weight of one big nail is 0.450 grams. So how many nails are there? We're going to take the weight of everything, 1,340. We're going to subtract the weight of the empty box, and you will get 1,127 grams. So that's the weight of the nails. Again, here is our equivalent statement. We have one nail equals 0.45 grams. So we're going to take 1127 grams, draw a line because we're converting. Whatever unit we begin with will be at the bottom because we want them to cancel out. So I will put nail at the top. One nail at the top is 0.45 grams. Parentheses, I'm going to cancel out my units. I'm going to put this in the calculator, 1,127, parentheses, 1 divided by 0.45, end parentheses, and I would get 2504.44 nails. So how many nails are in this big box? Approximately 2504 nails. Because we can't have 0.44 of a nail. Looking at this bottom problem, how many atoms are present in 320.7 AMU of sulfur? We're going to have to whip out the periodic table. We're going to see 320.7 AMU S for sulfur. Looking at the periodic table, we can see that one atom of sulfur is 32.07 AMU. So I can put one S atom at the top. My AMUs will cancel, leaving me with atoms. So in the calculator, I do 320.7, parentheses, 1 divided by 32.07, and that equals 10 S atoms. Great job. Now, here's 6.1, understanding the mole concept and Avogadro's number. And you're also going to learn how to convert among moles, mass, and number of atoms in a given sample. The mole. When we think about 12 eggs, we think it's 1 dozen. So when we think dozen, we think 12. 12 carbon atoms, we could also say that's 1 dozen carbon atoms. 1 dozen eggs. 24 eggs, we would say it's 2 dozen eggs. 24 carbon atoms, we'd say it's 2 dozen carbon atoms. C for carbon. 144 eggs, that's actually called 1 gross eggs. So 144 carbon atoms would be 1 gross carbon atoms. Now, the mole is a unit, which is, it represents a number, just like dozen represents a number. So 6.022 times 10 to the 23rd eggs is 1 mole eggs. This number is also Avogadro's number. So 1 mole will always have 6.022 times 10 to the 23rd. So here we have 1 mole carbon atoms. The mole, abbreviated MOL. A sample of an element with a mass equal to that element's average atomic mass expressed in grams contains 1 mole of atoms. So if I'm looking at 6.94 grams of lithium, this is equal to 1 mole lithium, which has 6.022 times 10 to the 23rd atoms of lithium. 4 grams of helium is equal to 1 mole helium, which is also equal to 6.022 times 10 to the 23rd atoms of helium. 8 grams of helium, well, if we look, 1 mole was 4 grams, so 8 grams will be 2 moles of helium. And that, we can just say 2 times 6.022 times 10 to the 23rd atoms helium. So, looking at the periodic table, 1 mole of any element is that element's average atomic mass expressed in grams. And every 1 mole will always have 6.022 times 10 to the 23rd atoms. Sometimes we'll also say molecules. We'll say molecules or atoms when we're talking about the mole. Now, how many atoms of H are in a 5-gram sample of hydrogen? So I'm going to start with my 5.0 grams of hydrogen. It's important to put your unit, and if you know what element or compound it is, write that down as well. Draw your line because you're converting. We're looking at the periodic table. It looks like 1 mole of hydrogen will have 1.01 grams. And we know that 1 mole is also 6.022 times 10 to the 23rd atoms of H. If I wrote out my long equivalence statement, right, it would be 1.01 grams of hydrogen is equal to 1 mole of hydrogen. And we know that 6.022 times 10 to the 23rd atoms of hydrogen. So I cross out my units. What do I put into the calculator? 5.0 parentheses. If you are not using a super smart scientific calculator, I would double parenthesis Avogadro's number all the time just to put that into your habits when you're putting numbers into the calculator. Divided by 1.01. So it's 5.0 parentheses 6.022 times 10 to the 23rd end parenthesis divided by 1.01. And then close that parenthesis up. And you would get 2.98 times 10 to the 24th atoms of hydrogen. I rounded to 3 sig figs in my answer, but if you're going for that A level, 5.0 actually has 2 sig figs, and so your 2.98 would actually turn into 3.0 times 10 to the 24th atoms of hydrogen. Great job. Now, calculate the number of moles and atoms in 10 grams of aluminum. So we're going to start with the number of moles first. So, first of all, let's find aluminum on the periodic table. It's number 13, and I know that 1 mole of aluminum is equal to 26.98 grams of aluminum. So I start with my 10.0 grams of aluminum, which is from the problem. Draw my line because I'm converting. If I started with grams of aluminum, I know grams of aluminum will be at the bottom, and I'm converting to moles of aluminum, which is always 1 mole. The average atomic mass is what we'd put at the bottom. Grams of aluminum will cancel because it's at the top and the bottom. When I put this into the calculator, I'd put in 10.0 parentheses 1 divided by 26.98 and parenthesis, and I would get 0.3706 and a bunch of other numbers moles of aluminum. If I'm doing sig figs, 10.0 is 3 sig figs. So I'd count 1, 2, 3, draw my line. How does the 6 influence that 0? We're going to round up. So this is going to turn to 0.371 moles of aluminum. Now I'm going to take that answer over here to figure out how many atoms that is. 371 moles of aluminum. I draw my line again because I'm converting. I know for every 1 mole of aluminum, I'm going to have Avogadro's number. Atoms of aluminum. So I know moles of aluminum will cancel. And what am I going to put into the wonderful calculator? Well, I'm going to put 0.371 times 6.022 times 10 to the 23rd. I know dividing by 1 doesn't change anything, so I'm not going to put that in the calculator. And I'm going to round my answer to 3 sig figs. So 2.23 times 10 to the 23rd atoms of aluminum. Great job. Now, here are some wonderful practice problems. Convert the following problems: 5.68 grams of silicon to moles of silicon and 0.496 moles of helium. Well, actually, that's hydrogen. Hydrogen to hydrogen atoms. Pause and then press play. So, I'm going to start with my 5.68 grams of silicon. Draw my line because I'm converting. Silicon is number 14. And I know that the average atomic mass is 28.09 grams of silicon to 1 mole of silicon. Now, grams of silicon will cancel, leaving me with moles of silicon. And what I'd put into the calculator is 5.68 parentheses 1 divided by 28.09 and parentheses. And then I would get 0.2022 and a bunch of other numbers, moles of silicon. I can round this to 3 sig figs because this right here is 3 sig figs. 1, 2, 3. How's that 2 going to influence that 2? We're going to round down. 0.202 moles of Si. If you already know that 5.68 times 1 doesn't change, and overall you would just do 5.68 divided by 28.09, wonderful. If not, you can just stick to putting it into the calculator as a fraction, and you'll usually always get the right answer. Remember, it's always top divided by bottom. Now, 0.496 moles of hydrogen. Draw your line. 1 mole of hydrogen is always equal to 6.022 times 10 to the 23rd atoms hydrogen. Your moles of hydrogen will cancel, leaving you with atoms of hydrogen. And I'm going to do 0.496 times 6.022 times 10 to the 23rd. Divided by 1 is still itself, and this has 1, 2, 3 sig figs. So I'm going to round my answer to 3 sig figs. When you look at your calculator, mine says 2.98592 times 10 to the 23rd. If I'm rounding to 3 sig figs, 1, 2, 3, how does this 5 influence that 8? It's going to round up. So I'm going to get 2.99 times 10 to the 23rd atoms of hydrogen. Cool, we've made it to 6.2. You're going to hopefully understand the definition of molar mass and learn how to convert between moles and mass of a given sample of a chemical compound. So, molar mass. Molar mass is the mass of 1 mole. The unit for it is grams per mole. It also looks like this. This is saying for every 1 mole, it has this many grams. Here's the example for H2O, which we know is water. We're going to list out our elements. and we're going to find their masses on the periodic table. Hydrogen is 1.01. We have 2 of them. Because of this number, it says I have 2. So 1.01 times 2, I have 2.02. Oxygen's mass is 16. I only have 1. Remember, if there's no number, it's an invisible 1. And then I'm going to actually add these numbers together. So it's 18.02 grams per mole. This right here is the molar mass of water. Molar mass. Hooray. Super nice, super easy. That's saying for every 1 mole of water, it's 18.02 grams. Let's calculate the molar mass of CaCO3, which is calcium, and then CO3 is our polyatomic for carbonate, or limestone, or Tums. So calcium is 40.08, and I only have 1 of them, 40.08, and then carbon is 12.01, and I have 1 of them. And then oxygen is 16.00, and there's 3 of those. So 16 times 3 is 48. We're going to add all these together. 40.08 plus 12.01 plus 48. You're going to get 100.9 grams per mole. That is the molar mass of calcium carbonate. Pause and calculate the molar mass for these, and then press play to check your answers. So, calculating the molar mass for vitamin C, I have carbon, hydrogen, and oxygen. 12.01 times 6, 1.01 times 8, and 16.00 times 6. 12.01 times 6 is 72.06. This is going to be 8.08, and 16 times 6 is 96. I'm going to add all of these together to get the molar mass. If you can hear bells, that's my cat in the background. 176.14, don't forget your unit, grams per mole. What about sodium hydroxide? Na is 22.99, there's only 1 of them. O, 16.00, also 1, and H, 1.01 times 1. You won't always have to multiply by 1 to show your work. If you know that those are all the ones together, you can just add them all together, but I like to show all of my work just in case you're not sure where numbers are coming from. Add these all together, 22.99 plus 16 plus 1.01. You're going to get 40.00 grams per mole. What about sulfuric acid? I have 2 hydrogen, 1 sulfur, and 4 oxygen. 1.01 times 2 equals 2.02. Sulfur is 32.07. There's only 1 of them. Oxygen is 16.00, and there's 4 of them. And 16 times 4 is 64. And we're going to add all these numbers together. 2.02 plus 32.07 plus 64. You get 98.09 grams per mole. My G looks kind of like a 9, but that's grams per mole. Great job. And that is the rest of 6.2, except for this one problem which throws it all together. Calculate the number of moles in 1.56 grams of C10H6O3. So in order to do that, we're going to set up our conversion. 1.56 grams of C10, H6, and O3. You draw your line. We need to know the molar mass of this compound in order to convert to moles. Because I know 1 mole will have some sort of molar mass. C10. Oops. C10H6O3. So let's calculate the molar mass. Carbon, hydrogen, oxygen, 12.01 times 10 equals 120.1. 1.01 is for hydrogen, and I have 6 of them, and that is 6.06. And then oxygen is 16, and I have 3 of those. I'm going to need to add these all up to get the molar mass. 66. Oh, oops. I calculated wrong. Now, you are going to add up 120.1 plus 6.06 plus 48 to get 174.16 grams per mole. This can be rewritten as a conversion factor where we put 174.16 at the bottom. So when we cross out our units, we are left in moles, and you get 1.56 parentheses 1 divided by 174.16 end parenthesis, and I'd want 3 sig figs in my answer, so I get 0.00896 moles of C10H6O3. There it is, the end of 6.2. Go do your wonderful homework. See you next time.